Today we're going to finish the last two, these two. The first one, DIY, I'm going to demonstrate. So the first one, I'm clicking this, the first item here, the DIY, and it's a very simple diagram. It is a LED point, connecting to D9 and then have a resistor going to ground. You can just go into the example, basic, this is a fake, okay. And when you have this one up started, this is the program. It's very simple one. It just go in, it writing something to the LED as loop back. So you can see the LED itself is slowly growing and slowly dimming. This next one is very similar. You can upload it to your program. The circuit is exactly identical. It's just using different type of program. If you go to monitor, so this program is interesting. I am generating a number out. So if you look at the program itself, I am just writing the number out here. And the potter is, I mean, the Arduino IDE potter, they are intelligent. When they see the number, the potter will just plotting the value. So this is internal value. If you look at the monitor, if you look at the monitor itself, it's just a whole bunch of numbers. See, continually grow, repeating. For those you never learn what is sine cosine, it's okay. Don't worry about it. The idea is so simple. All the calculator and all this C program, they have some built-in function called sine. Internally, they're doing it. So what is this doing is, when this symbol is a degree, when you fit the degree into it, they will give you the length for sine, the length of the green one. Okay? So if you put, you're assuming this radius 1. So when you put 0, the green will be 0. But when you put 90 degree here, it will be 1. So if you put 45 degree, it will be, I forgot what's the value. Cannot pop up on my mind. And in the meantime, there's another called cosine. For you, if you don't learn this one before, or you just treat it as a function, okay? You put in something there, they will give you a magic number come back. So in this trigonometry, we put this number here, let's say 45 degree, they will give you this green length, the length of the green bar here below. If you put the sine, they will give you the green, this blue bar for the cosine, the green for the sine, okay? Now, this is the theory, okay? Let me load a program. This is the program. And then I'm going to put into a new program. So this one, I intentionally doing sine and cosine output, but I also using this switch. If you're changing this one to high and low, meaning you want to see it, you don't want to see it. So what this program doing is, it doesn't have any output. Now what it does is, I fit in from the degree from 0 to 360. I'm just continue looping this degree into it, okay? So, and I also like divided by 100. I mean, because 360 is going all the way up. So if I want to do it, I would like to just scale down. So I divided by 100 to scale it down to some visible one. Now, the green one is the sine curve. What I mean is, I probably cannot stop it. Can I stop it? Okay, basically, what is this? Can I stop it like this? Good. Now, what it does is, when I give the value 0, and then the sine function, remember the function, it will give me this value 0. So when I getting the value higher, the sine function will give me a different value back. So if I do it slowly, plot it, this is called potter. So we plot it in here, 90 degree. We will see the sine number is going down. Okay, so this is 180, somewhere around 180 here. If you look at the circle, 180 is almost like opposite side, and then continue to grow to 360. The sine curve will give you a negative number. Remember, this is 0, okay? So you give a negative number. So you plotting the curve is like a cycle. I'm going to enable this cosine curve. So the doing it is I'm just basically say hi here, meaning I like to enable the cosine together. So now if I look at the plotter again, this will be an interesting thing. You can see the blue one is still the input from 0 to 360 degrees, and the green, the red one is the sine curve. Oh. And this is the cosine behind it. Okay. What it does? Voltage increase. Sine and cosine. Yeah, this is able to you to plot the sine and cosine curve. So I'm going to put in another one is. What it does is in this loop. Previous is only looping from 0 to 360 and then drop back to 0. So I don't want to see more. So this one was skip it. Now I want to back from 360 down to 0. So you can see the curve is going up and going down, not like the sharp going down. So let me compile and do it again. You will find the math is very interesting. So basically, it's just like before. Now, you see when it goes down from 360 down to 0, the sine curve is going this way. Okay? And then the cosine. The cosine sine wave. I think the cosine is not doing anything. Waveform. Remember at the beginning, we telling everybody a digital circuit is 1 or 0. Okay, and when we waiting to the LED, we usually say digital right, high or low here. But in this program, I am using the analog right, just the value, and then the LED is according to this value is going brighter or dimmer. But remember, LED is only on and off, okay? So let me doing a chart to say what is going on. Now, previously we learned the so-called digital is from 0 to 1 or 1 to 0, and sorry, this one, 1 or 0, on and off, true or false, high or low, +5 and -5. This is digital. So it just only have 2 values. However, we are living in the analog world, meaning like we will have someone in between. This is called analog. Now, you probably want to control your robotic arm from A to B position. You're not controlling the robotic arm from all of a sudden from one side and to the other side and from one side. This is not possible. This is not the way we want it. So we have to handle in analog world. Okay, the analog. What does analog mean? Basically, it's an infinite number in between 0 and 1. That continuous. And that's another way to say analog is from 0 voltage, meaning no voltage, all the way to 5. So I'm just making an example. There's an infinite number in between. Okay, and like a degree, we have 0 to 180 or from 0 to 360. In between, it can be a decimal. Now, I guess up to all the previous one, we learning everything is integer. So it's just have the beginning, it's only have value at the, let's say just 2. But in the computer, you need to dealing with this called the analog. We call a floating point, okay? We call this analog, meaning something more than just an integer, called a floating point. So in our case, we call it analog, okay? Analog is the one to controlling the pin. So let me show you the program. Now, Remember previously in the day one, we're using the so-called the digital write, and then true or false here, high or low, 1 or 0. Now we're using the analog write to this LED and the value. Okay, this value is from 0 to 255. Okay, so it can writing this brightness from 0, no line at all, up to 255, the brightness. All right, and how you can do it? Because LED itself is just on and off. How can you control it? Like here, you can see it doing a different brightness. How can it just LED just able to doing on and off, able to achieving this? So this will explaining what is going on. Okay.
Previous project, we have tested Arduino digital programming. In this project, we are switching to Arduino analog programming. This diagram explaining the difference between digital and analog signals. Digital signal has 1 and 0 values where analog signal is continuous. The signal value depends on the electronic device, how fast is the reading cycle, and the size of the computer varies. Arduino has 6 analog pins from A0 to A5. Since Arduino operates in 5 volts, so its analog pins are working between 0 to 5 volts. Arduino A, D, analog digital. Converter will translate the 0 to 5 volts to integer value 0 to 1023. We know music is analog signal. Why we can play tone with digital pin in programming? The answer is PCM pulse code modulation. Arduino programs send digital pulses to speaker pin. We can hear low frequency with lower pulse rate. We hear higher frequency with higher fuel rate. When the program sends a fixed frequency to speaker pin, we hear a tone. When the program sends out tone by tone, we hear a song.
In the Arduino, they have all this one is called digital pin, meaning they just have 0 or 1. Okay. And in the meantime, they have 6 analog pin. This one can generating the output from 0 to 5 volt, somewhere in between. That's why they call analog pin. And in the digital pin, they can only have 0 or 1. The question we have is, how can we connecting a speaker to a digital pin, but we hear the sound or the tone? So the way is we're using something called pulse co-modulation. What is the pulse modulation meaning is remember computer is very fast. It can using the computer to pushing from 0 to 5 volt in a very fast sequence. So in making this the vibration of the air, they don't have to using the negative side. Remember last time we talked about you pushing the positive side, the cone will push it out, the speaker, the cone of the speaker will push out. And then when they have the negative, the cone of the speaker will pull it out, pull it back. So you're doing this vibration to doing to generating the sound. However, in the using a digital pin, you can simulate the whole thing. You can just have 0 to positive. You can still have the speaker, the cone of the speaker, push out and come back, push out and come back. So it doesn't go backward, just push out and come back. If you writing this fast enough, and then you will hear the low frequency and high frequency, just like
programming. The answer is PCM pulse code modulation. Arduino programs send digital pulses to speaker pin.
Okay, so when we're using this so-called the pulse code modulation, it will generating the true of the on and off in a very high frequency. Okay, and then if you pushing the speaker, they will generating the same sound wave as we want it. So when we hear it,
we hear higher.
As a human, we fooled by this sound wave. We thought you just have a positive side, you don't have a negative side. But for us, the human, our brain will feel the other side. Okay, they will think it's similar. That's why in the PCM modulation, the sound is not quite natural, but at least you can hear the sound. That is how, in the previous experiment, you can using a digital pin to creating some music. Now, for the LED, we're doing the same thing. Our human eye is fooling by they bringing really fast frequency. Okay, when they bring in lower frequency, we will see the light is dimmer. When it's flashing in a very high frequency, we will see it the brighter. Okay, this is triggered by our human brain. I mean, the computer is just doing very fast. You see in your Arduino, they have the curve sign in the 11, 10, 9, 6, 5, 3, this 1, 2, 3, 4, 6 pin. This curve sign basically meaning you can using this pin to generating a PCM signal. The other one, you can write it, but it doesn't do it very well. But this one is the hardware built into supporting when you're just writing a value like this. This is pin number 9, okay? And you can just writing a from 0 to 255. The hardware will generating the PCM pulse for you. So when you have the program like this, you writing the pulse, the brightness into this analog right to the pin 9. It will generating a different intensity from the human. Just one line, we will seeing this LED changing a different brightness. This is how Arduino or most of computer today handling the analog. Now, however, you do have an analog pin with generating a real analog signal. Okay, I mean, we're using the digital pin to simulate a digital analog signal by PCM, but we can also have the real analog pin to generating the voltage in between 0 to 5 volt. And this one can also reading in from 0 to 5 volt too, right? Let me explain variable resistor. Variable resistor, basically, we have using the regular resistor, just one of the fixed resistor. But we also want to changing the resistance. So we can using a variable resistor. If you have your own kit, you will have something like this. And our kit is distributed like with the smaller version, okay? So what it does is, this is the symbol, a resistor symbol. Now, this is another way to explaining what's a variable resistor. So they have a ring, which is a resistant, but some material is a resistor. So when you changing this wiper, and they will generating the different value from A to B or from B to C. So when you change it, you can just all the way to 0 ohm, all the way to whatever the ohm is. The other side is reverse. So when this wiper going close to the C, this one will be 0 ohm. The other one is the maximum, all right? Again, that's the three most common version of the variable resistor. One is that this is big one, probably almost a 1/4 inch big. And this is very small one in your box, in the kit. And the good thing is this small one, you can just plug into the breadboard right away. Now, I'm picking two pictures, so both sides, so let you easier to understand. So when you plug it in, one of the row is the A, and you think about internal is like a ring, okay? And then when you turn this, using a screwdriver to turn this, it's just a wiper. And then when you connecting to the other side is a B. So the other side is B, just right on top of here, this is B. This the bottom one is popular, but when you working in the circuit, and because you cannot plug in, this pin is too big to plug into the breadboard. So we don't have this one. But in case, if you have your own kit, and then you need to using your own variable resistor, you can consider A, B, C, same as this one. Okay, this is finished the variable resistor. Now, for the variable resistor, we would like to generating a different voltage. Remember, we just talked about analog. So analog, we like to generate a different voltage by turning this variable resistor. If I explaining a variable resistor as a series of resistors together, okay, from 5 volt to the ground. So meaning if the total is, let's say, is 100K. So if I have the B here, I will get zero voltage, meaning I get value 0. If I jumping ahead to this one, it will get 0.5 volt all the way. In the middle is 2.5. So in this diagram will be something like in here. And this one is dividing the voltage, 5 volt to, in this diagram is a very rigid, it's a 10 resistor to simulating a variable resistor. But the idea is when you have a wiper, like the blue one can be moving up and down, so you will have an infinite number of voltage in between 0 to 5. This is how the variable resistor works, okay? And today at the end, we will using this one called LDR, light dependency resistor. When you're shining the light into this resistor, the ohmage will become close to 0. When you blocking the light, the internal resistance will become a few mega ohms. So it will depending the light, how much light you're shining into it, they will generate this one resistance. Now, why don't I just cannot connecting from here all the way to down? Because when you're shining a light to here, it becomes 0 ohm. Then it's short circuit. Without this resistor, without this 10K resistor. So I have to put the 10K resistor here to protecting this circuit. Like if this one becomes 0, this circuit is still have 10K, okay? But of course, you will getting, if you're very bright, you will getting the 0 ohm, so the value will be close to 5 volts. But when you blocking it, it's almost become a very high voltage, very high resistance. Let's say infinity high, okay? So in that case, this voltage will come close to 0 bytes. So this is how you generating, this is how you using this circuit to providing the so-called voltage divider. They will dividing the voltage analog signal by variable resistor or by this LDR, light dependency resistor, okay? Today's we're going to build this. This is what we're going to build today. You have the previous speaker pointing to DH and the ground. And then in the other side, you're using this variable resistor. The B, this is the B to the A0, and then the positive and negative. And then after you finish this one, you can, using this program, you can upload this program into your Arduino, okay? And later on, we will doing the same thing for this side, but let's doing this one first, all right? It's very annoying, but when I turn this resistor, let me stop it. So annoying. Okay. So what it does is, this is so-called the voltage divider. It have a 0 and a ground from 2 A and C. So when the time I turn this variable resistor, this will generating a different voltage. Feed it into the A0. And then in the A0 program, they read it, they will know that it's close to 5 volt or close to 0. The program we just have, we will using this value, analog value. It's not true or false. It's from 0 to 5 voltage to generating different tone to control the program. We can using a different way to see how to getting the analog signal. But using a speaker is very obviously, like, because you can hear the sound is being changed, okay? That's why I'm choosing to using a speaker, beside the speaker can playing some kind of music. So it's more fun to using the, using it into our Arduino programming education. Now see, when the time I'm blocking it, so basically, it depending on the number of, the brightness shining on the LDR, they're generating different voltage going in. they will doing, look at the loop is more important. So you will have an analog read sensor pin A0. At the beginning, you're reading the analog value from the A0. Now, in the Arduino, when it read in from 0 to 5 volt, the value is internally from 0 to 1023. So when you have 0, there was 0. When you have 5 volt, it's a 1023. Okay, so this is the value read it in if you changing the variable resistor or changing the shining the LDR on the light or not. This value will be between from 0 to 1023. And in the Arduino, that's a function. They get this value, map it from this one to -10 to 10. Meaning, if you have a 0, the value will be get back to you is from -10. If you got the 1023, it will give you 10. This is a mapping. This why this value this function is called mapping. Basically, mapping the value from the original one, the range. This is the input range. This is output range. So, and then you pay the tune. The pay the tune is directly paying to the pin itself by using a function below. Okay, I mean we don't have worry about how they're generating the tune below. We just concentrate in the main program here.